Welcome everyone to the 11th live stream in this DevVenture of creating a space shooter game. I would like to apologize that the camera isn't working today. I had some technical difficulties setting up my camera, and rather than delay the start of this live stream trying to set that up, I decided to just leave the camera feed for this live stream. So in the last session, we were working on trying to separate all the separate modules. Well, all the modules that we want separate, right? So we wanted to modularize the playership. Well, the player. We wanted to modularize the player into a first-person controller, and then a health and damage system. Well, a health system and an attack system or a damaging system, right? So receiving damage and inflicting damage separately, because each player mode has differences in how they receive damage and how they inflict damage. And those differences aren't necessarily the same across the modes. So we want to make things as modular as possible, and by doing that we have much more control over everything, and we can fine-tune things as we see fit, even during runtime, if we do it this way. Now, the first thing I want to do is make sure okay, so if I go into the script file for the enemy ship behavior, all right, so this I have set up for a single mode, a single gameplay mode, which isn't the best idea, because by doing it this way I've now limited the pirate ship to be only an NPC enemy, and everything is in one place, which is again not the best idea. Plus, in this case, I've got the left gun and the right gun, whereas in the actual code, well, the scene setup for the pirate ship, we only have one gun, the main gun. So let's change that. We'll go back into script and change we'll change the right gun to the main gun, and we'll copy this node path and paste it there. And now we go and find all the cases where we are using left gun and change it. So this whole thing, from there all the way up to here, we delete all of it. And from here we change right bolt to be main bolt. So let's copy this. Oh yeah, okay, fine. Here we'll change that to be main bolt, and then here, there, and there we paste it, and then, well, there as well. Okay, done. Also, one thing I wanted to point out that I forgot myself and only realized yesterday is this. Here you can see a list of all the functions in a script file without having to search for it in the actual script body. So for example, if I go to a really large script file, like player behavior, for example, and I scroll through it, you can see it's really long, right? But what happens if I want to go from the very bottom of this to one of the top ones without like clicking here or scrolling up here? I can just click here. So let's see. If I want to go to extract pure your pitch, I can just do that. Click on the the function item here, and it jumps automatically to the declaration of that function. Because when you say func, which is short for function, you are declaring this function. So this is a function declaration. And wherever there's a function declaration, it creates an item in this list. It's so convenient. I don't know why I didn't use it before. Anyway, so let's go back to the enemy ship behavior. Oh, that's the documentation. Here, right. So we've only got one gun, the main gun. And we've got one projectile, the main bolt, right? We've set the scale, which I don't think we should do. I don't think that's a good idea. Let's see, this column is 46. This column is also 46. So let's move these out. There, and there. Okay. Can shoot, destroy, take damage. And then it's got a seek function, which is here, and an accelerate function, and a process function. So what I want to do is create a fourth, because I've got three, right? I want to create a fourth scene. So I go to scenes, entities, and here are my entities: defender, miner, and pirate. But I want to create a fourth one, which will be the containing scene, like the generic scene, okay, for player. I'm going to make a scene called player.tscn, and then I will make all the accommodations for the modular code. And then at runtime, for any scene, I'm going to make it build up one of these three scenes from that scene. And then we won't need these anymore, because it's the same thing. Ideally, it's the same thing, right? But we will actually need these still as NPCs, right? So when you're playing as a pirate ship, as the player, then these become your NPCs. And if you're playing as this as your player, then these two become your NPCs. And if you're playing as the defender, then these two become your NPCs. And that way, you now have just trying to get my wording right. You have a separate class, well, a separate scene for when an entity is a no player character and when that entity is the player's character, which lets you then have separate controls and separate functions and separate scripts and everything. So I don't have to do away with this code. I can keep this code for when the pirate is an enemy ship. And I hope that makes sense to you. Okay. So let's get started with that. We'll create a new scene. We'll call it player.tscn. Extends character body 3D. And then we can open up the scene. All right. Now, the player scene is a character body, and as you can see here, it's complaining. It doesn't have a collision shape, and a collision shape needs a shape, right? So we need to give it two things. We need to give it a collision shape, which is this. Just do this, so you can see, right? Collision shape 3D has no shape. And it also needs a mesh instance 3D, which needs a mesh, right? Now, what we need to do is define those convex polygons that I told you about for each of these mesh instance 3Ds. We need to define a convex hull around each of them and save them. All right, so how do we do that? We can do that in Blender. So if I go into the collision shape and I say convex shape 3D and I open this, you'll see that there's an array of points. Right, so let me go here to 1 second. I see there's a complaint. Oh, yeah. Okay, so it's saying it's failed to build a convex hull because there are 0 points. That's fine. It will go away once we add the points. Or we just do away with that for now. Alright? So let's say I want to load a shape, a T-res, a res, or a shape. .shapefile. Okay, let's go to DeepSeek and ask DeepSeek what it suggests for importing a custom convex hull without defining it in Godot engine. Okay, so let's say I want to use a predefined collision shape using Blender How can I save this collision shape in such a way that I can load it as a collision shape in Godot engine? My plan is to preload these shapes and assign one during runtime. Preload 3 of these shapes and assign one during runtime depending on the player's choice or slash setting before runtime. What do you think? Oh, this is the wrong chat. My mistake. Let's go back to this one. Copy this message and paste it here. It has no context of the other game, so that's why I'm switching. This one. Here we go. By the way, the same prompt would apply to that game as well. Because remember I mentioned I'm making 3 games. So this kind of implementation would work in that one as well. That's why I didn't delete the prompt or the response. But yeah, this one does have the context of our current space shooter game. And so it's a better location for this prompt and for its response. I think it's still busy loading an answer here. So just let it finish. And then go to this one. And now here we go. This is a great approach. Using pre-made collision shapes from Blender gives you more precise control than Godot's primitive collision shapes, and here's how you can do it. Exporting from Blender. Create your collision shape as a separate mesh in Blender, and then export as a GLTF or an OBJ. Keep it simple, use low poly geometry since it's just for collision. Yes, exactly, okay. And then in Godot engine, import the mesh and create a convex polygon shape 3D or concave polygon shape 3D from it. Then preload your shapes. And then assign it at runtime. Considerations. Concave versus convex, or convex versus concave. Use a convex polygon shape 3D for performance. Recommended for moving objects, as a concave polygon shape 3D is more complex for and meant for static shapes. Okay. And then in terms of scale, make sure Blender units match Godot's. 1 unit equals 1 meter. And the origin, center your collision mesh at the origin in Blender. This approach gives you artist-controlled collision shapes with the flexibility to switch them at runtime. So now I need to ask it, I see that Godot is looking for dot res dot tres or dot shape files when I try to load a collision shape from the editor. Will your approach cause problems knowing this requirement? So just in case you didn't get that, when I say load, you see here tres, res, or shape. it doesn't accept others. Well, I mean, it does, but these are the recognized ones. See, all recognized shapes are these three. And an OBJ or a GLB file is not one of these. So there's a workflow I'd need to do to get these to become, to get those shapes to become a TRS file. And that's what I'm asking DeepSeek about. Server is busy. Is there a problem with my internet connection today? What's going on? Okay, while we wait for that, we'll just open up Blender in the meantime. Then we can get started on those collision shapes. Okay, we'll delete that one. Then we'll import file, import. Then we do this here. I'm just navigating through the file explorer, trying to find the models. Okay, let's start with the defender ship because that one had the most problems. Defender ship with no gun. Right, here we go. Now, if I go into edit mode, so let's create a new object. Here, new, oh, that's a new collection. Here. So I can say shift control N. Oh no, it was shift A for add. I'm in object mode, right? Yes, okay. Add a new mesh. And then we'll just do a cube for now. We'll call this convex hull dash defender. Or we'll say, yeah, convex hull dash defender ship. Okay. Now we can say tab, go into edit mode, and begin. So now I need to do this. I need to go how do I do wireframe? I was hoping that this wouldn't become wireframe. Fine. We'll just do this. Say face, add snapping, snap to face, enable snapping, and then grab Y, snap to face. Go to vertex, enable according to vertices, grab this, and snap there, Okay, and then this one, let's just do this. Let's say that, and that. Only faces. Select the edges. Mesh. Edges. Subdivide. And subdivide again. Okay. I'm just going to do this again. Select all. Go to mesh. Face. Edge. Subdivide. Yeah. And then do that again. And again. I can actually control it here. So undo, undo, and undo. And I can say edge. Subdivide. Over there. You can do the number of cuts. 2, 3, 4. Okay, then I can say select all, delete only the faces, and now we have a cage. We can build our collision shapes using this cage. And we've got snapping enabled according to vertices. So let's do this. You can go there. So this is a bit of a time-consuming process, but it's a lot easier than doing it in Godot engine. So you'll just need to bear with me. Don't worry about overlapping vertices and edges. We'll clean that up once this is all done. Okay. I'm sure there's a faster way, like using the shrink wrap modifier or something, but I don't actually know. So for now, this is just the best to do. Okay, that seems fine. So again, we're not looking for perfect fits around the whole shape. It just needs to be convex. All right. And as you can see here, that's concave. There's a concavity there. So what I need to do is I need to select this and then grab something. Grab along the x-axis. No. We'll just grab Shift Z and then move that until it's convex. Something like this. Yeah, that looks good. And then this, you just move that up. Again, we want it to be a convex arc over the ship, not to concave like this. That's still convex, that's good. So then we are good to keep going. But remember, we want it to be efficient. Minimum vertices. So we don't need those over there. Just turning off snapping there so that I can get more fine-tune control. Still seems convex to me. Good. Now we need this to snap. Oh yeah, we need snapping. To snap there. No. There. Yeah. Okay. Because again, it needs to be convex. And then you can snap to that. And you can snap there. No, you won't. You will snap there. Like this. Almost there. Just a few more things. So you and you. That's not convex. I'm wondering if we even need to include the wings, because there's a lot of empty space here if we do that. Okay, let's leave the links. The wings. Let's leave the wings. Ignore all the wings. Okay, so I realized that this is taking a very long time. So what I'll do is I'll do the other two in the gap between this live stream and the next live stream, which will be on Monday. Yeah. And then also I apologize for the long silence. Let's try and get this response before the end of the live stream, shall we? Perhaps it'll work this time. Also notice that this theme has changed. I'll have to change it back. Okay, so here's what it says. You are absolutely right to point this out. Godot does prefer tres or res files for resources in the editor. My approach would work in code, but wouldn't be editor friendly. Better approach, create .shape or tres files. Import your mesh, right click the mesh, create new convex collision shape, or create new tri-mesh collision shape, and then save as a .shape or tres file. Preload the shape files, and then alternative, create them programmatically. If you really want to avoid .shape files, then you can create them programmatically. Why shapefiles are better? The editor can preview them. It's faster loading because it's precompiled. You can share them between multiple objects, and it's easier to manage in file systems. Your instinct was correct. Using proper Godot resource files is the way to go for better editor integration. Okay, good. Then we can proceed with that. So we'll need a convex shape before we can make a shapefile, right? So let's do that. Okay, let's just check everything is symmetrical. We don't need these. Because it makes things concave. So what we can do instead is just do what they call a triangle fan, and that will keep things convex. So it's convex, and there are some gaps. All right, but what we can do to make those gaps smaller is we can shrink this down to exclude these fins because they are pushing this vacuum wider, right? So let's not include them by doing something like this. We can grab that vertex and put it there and put this one here. No, but then that upsets the topology of everything else. So unfortunately, wait, why is this vertex so much higher? Convex, 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 concave. Turn off snapping. Convex. Convex. Alternatively, we could just delete these and join these directly. Oh yeah, snapping needs to be on. So like that. Happy. So again, I'm trying to find the minimum enclosing shape that is convex for this polygon. And now, since we know that this face is the most extreme on the left and on the right, we can bring them in to coincide with the furthest point on this jet, right? So let's do that. Grab on the X and snap to that, like that. And the same thing here, there, 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 and there. We can snap it onto this vertex. Okay. So I'm going to end the live stream here because it's gone over an hour. So thank you for watching and thank you for your attention and your time. And then I'd like to make a shout out to Cubes. Thank you for your support. And then I will see you in the next live stream on Monday.